move on in lesson 2.6. Here's, first of all, we have a couple of learning goals. Let's look over here. I can write a compound inequality that represents a graph. So in other words, they're going to show you the solution set on a graph, and you're going to write the algebraic form of it. What does that graph show us? And it's going to be a compound inequality, okay? And then it says I can represent a real world problem with a compound inequality in the graph. Well, as soon as you see the word real world problem, you know it's a word problem, right? We're going to represent those with a compound inequality and then show the graph for that also. Okay, so let's start with our first learning goal, which is writing a compound inequality shown on a graph. So what you're going to do is you're going to represent the shaded regions. So in other words, we're going to look at that graph, we're going to say what's shaded. And then you're going to have to decide, should it be an and or an or compound inequality. So you're going to have to make a choice between and. When we have an and, we know that means we have one inequality with the two simple inequalities combined together with a variable in the middle. That's our and one. When we have an or one, we know that we have two separate simple inequalities. So each of them has their own variable, and they use the word or between those two simple inequalities. So you have to decide, when it's an and one, do we write the word and? Yeah. We don't, because we just combine it into that one statement. But when it's an or, we do write the word or. So we typically, you will not see the word then written with the word and. Does that mean you couldn't write it that way? Doesn't mean you can't. But in an answer bank, they're not going to show it written that way, so we just need to make sure we understand how to do it right away from the beginning. So is number 11, this is problem number 11 from the book, and so all I did is reproduce the graph here, and we're supposed to, the directions say, write the compound inequality shown by that graph. Is this an and one or an or?
It's an and.
This is an and one, when it's contained between two endpoints. Those are typically our and one. So let's just write that right here. Let's show that this is really an and one. So that means our variable is going to be in the middle region, and those are our endpoints out in the outer regions, aren't they? So what we have is we have -5 at this end, and we have -3 at the other end. We have x in the middle, and is less than. That's typically how it is, because when you read it from the inside out, here's what it says. X is greater than -5. Is that what's going on there? Is this part here that's shaded in between, are those numbers greater than -5? Yeah. And x is less than -3. So are those numbers that are shaded less than -3? Okay. Are -5 and -3 included? Are either of them included?
No.
One or both of them? Is -5 included? Yes, because it's shaded in, so we put the equal to bar. Is -3 included?
Yes.
Yes, so we put the equal to bar for that one. We have to look at each of our endpoints and see if they're shaded in or not. If they're shaded in, that means they're included in the solution. If they're not shaded, that means they're not included. So what we're doing, instead of having to solve, we're showing what is the solution algebraically, and then they already gave us the graph representation of it. Okay, so here's our answer for this one. We have shown the compound inequality that represents that graph. Okay? Let's reproduce the graph that they have for number 12. Remember, I don't make you do all those extra numbers on the number line. I said yesterday in the notes, I believe, that you can just do no integer neighbors, you can just do the endpoints. So for number 12, what are our endpoints?
-3, 3.
-3 and +3. Everybody see where we're at in the book? -3 and +3. Okay. Is -3 got a shaded in circle at it?
Yes.
Okay, so we'll do that. And how about +3? Does it have a shaded in circle? No, okay, so we'll not shade that one in. And it's shaded to the left of -3, so get that shaded, and make sure you can tell that that's the part that is shaded. Make it fat, do the squiggle thing, whatever way works for you. And then it's shaded to the right of the +3, so again, we want to show how it is shaded. Okay, now I want you to try and write the inequality, compound inequality for that one. What do you think it would be? Is this an and or an or? This is an or one, isn't it? When it goes out from the endpoints, it's saying it can come from this region or the other region. This is an or one. When it's an or one, we have to use the words or and write two simple inequalities. Okay, what's the first simple inequality for this one, Jesse?
X is less than or equal to -3.
X is less than or equal to -3. Next, we put the word or. We have to use the word or when we write a compound inequality for those situations. And what's the other simple inequality, Cody?
X is greater than 3.
X is greater than 3. We did not have shaded in circles, so notice we do not include the equal to bar on the second simple inequality. Cody?
For the first one, could you go -3 is greater than or equal to X?
Yes, you
Still
could.
have it the same way.
It still would be correct. -3 is greater than or equal to X. That works also. Any other questions or concerns? Okay, number 13, reproduce the graph on your paper that is shown in the book. So for number 13, once you have your graph reproduced from the book, decide if it's an and or an or, and then set up your compound inequality and see how it goes. And by the way, you get to pick whatever variable you want to use. So if, let's say you look in the back of the book for an odd number problem like this and they don't have X, they have C instead. Would that be wrong? No, you get to pick any letter you want to represent the unknown. Okay. So first of all, is this an or or an and?
It's an or.
This is an or. Okay. So Noah, what's the first simple inequality in this one?
X is less than 1.
Okay, and then we bring our word or in between them. Aurora, what's our second simple inequality that makes up our compound inequality?
X is greater than or equal to 9.
X is greater than or equal to 9. Do all the rest of you agree with this? Do we have a good compound inequality to represent that graph? X can be less than 1, it can be any number less than 1, or it can be any number greater than or equal to 9. Okay, why don't you finish up with 14 now then? Reproduce the graph on your paper first, showing what your compound inequality is going to represent. And I expect you to do the same thing in your homework. The and ones are sometimes they feel like the trickier ones to actually write because we don't use the word and. We bring it together instead. and one, right? Do you agree with me it's an and one? Okay. If we use the word and, which it would be pretty rare that you would see the word and. I'm not saying that you might not ever see it that way, but it'd be pretty rare that you would see it written this way. But if you did, would this be correct? Does that represent that graph? X is greater than or equal to 4, and X is less than 8.
That's right, but it's not written in the right way.
It's just not written in the form that we would see it in, is it? But, so this one says X has to be 4 or more, but then it also has to be less than 8. So in other words, it's saying it has to meet both conditions, doesn't it? Now, how does it become where that X is in the middle? So here's what I want to show you. I want you to see that, can this one be written like this?
Yes.
Can I turn that one around? Remember how we could switch them around? We have them trade places and then the inequality symbol reverses. So is that the same thing? 4 is less than or equal to X?
Yes.
Is that the same as X is greater than or equal to 4?
Yes.
Okay. So notice now what happens. 4 is less than or equal to X, and then we don't, instead of using the word and, we don't write the X again, we just bring down the other simple inequality is less than 8, and there would be our compound inequality. Is that what you have? 4 is less than or equal to X is less than 8. How many of you were successful? Okay, Cody, what's the question?
I put 4 is greater than or equal to X, and less than 8.
It's not though. 4 is not greater than or equal to X, because remember this is X. Oopsie, I didn't mean to erase that. Yeah, let me undo that here first, here quick. Do erasing. Okay, so, thought I undid it. Okay, so is 4, this is X, is 4 greater than X in that drawing?
Well, if it was less than X, then wouldn't it be going that way then?
No, it's 4, when you start with the number 4, you're saying that 4 is greater than all these numbers in between here.
But less than 8.
But less than 8. No, 4 is not greater than those numbers. 4 is less than those numbers. And then less than 8. So you could not write that 4 is greater than or equal to X. It has to be 4 is less than or equal to X. Okay, so this is our final answer for this one. One in the black on my board. Okay, make sure you have it correctly in your notes. So any questions on being able to write the compound inequality for the graph represented? Okay, let's go to the back then and let's do the other learning goal we have. Being able to represent a real world problem with a compound inequality and a graph. So we're going to do just like we always do with our word problems. Pick a variable and describe it. Write the and or the or compound inequality that you need to represent the situation, and then graph the inequality. These will not require any solving. That should already be by itself in the inequality when we get it set up. So let's look at number 2. An iguana needs to live in a warm environment. On the top of the page, 138. Follow along. An iguana needs to live in a warm environment. The temperature in a pet iguana's cage should be between 70 degrees Fahrenheit and 95 degrees Fahrenheit inclusive. What does that mean, inclusive?
In those 2 points.
Yeah, so basically, they're talking about just those 2 endpoints. What are they saying about just those 2 endpoints when they use the word inclusive? Cody?
No less than 70 degrees and no greater than 95.
Okay, so what are they saying about the endpoints? Are they included or not? Yes, inclusive means they are included. So when you see the word inclusive, they're saying you need to include that endpoint or those endpoints. So in this case, there's 2 of them. There's 70 and 95. They're saying you need to include them. Noah?
Is there a word that tells us if they're not included?
What they would say instead is the temperature in a pet iguana's cage should be between 70 degrees Fahrenheit and 95 degrees Fahrenheit, and they would stop right there. That would mean anything between those 2, but don't include them. So there is not another word. They just would leave the word inclusive off, and you would know not to include them because it says between them. Okay? So it says in between them, basically, but if the word inclusive is not there, you do not include the endpoint. When the word inclusive is there, you do include the endpoints. So write a compound inequality to show the temperatures that are within the recommended range. Graph the solutions. Now, sometimes I think students find it easier actually to graph first and then write the compound inequality. But what's the first thing we're going to do though? We're going to pick a variable and describe it. So what variable should we choose?
A.
X? Okay, I heard X first, we'll go with X. X is what? What is X?
The temperature in the iguana's cage.
Okay, the temperature in the iguana's cage. And what's it measured in?
Fahrenheit.
Okay, so temperature in degrees Fahrenheit in iguana's cage. Temperature in Fahrenheit, degrees Fahrenheit in iguana's cage. So what is the shaded region? What is the X? What is that representing in this problem? Okay, so again, you have two choices here. You can either graph that first because it makes more sense to you to see the picture of it and then write the compound inequality, or you can write the compound inequality first and then do the graph. Okay, go ahead and try it. See what you think it should be. The temperature in the iguana's cage should be between 70 degrees Fahrenheit and 95 degrees Fahrenheit inclusive. So I grabbed mine first because I like pictures to help me make sure I make sense of the problem. How do you like my graph? Think it's good or not? Does it represent what the problem says? That the temperature should be between 70 and 95 degrees. That's the shading between the two numbers, right? And then inclusive, remember we just had that talk. We said inclusive means you include those endpoints. So do you like my graph? Do you have the same graph? Okay. Is this an and or an or? This is an and. So that means I'm going to have my variable that I chose in between those two endpoints. Cody?
Could you have an and that goes from, like, say you have the 70 degrees and it goes like anywhere through 95 goes to the right?
Goes from 70 to 95 and then beyond 95, is that what you said? Could you have an and that goes like that? Yes, you could.
I was wondering that too.
You can. Typically we don't, but you can, yes. What does and mean? It means you have to have
This
all the ones that work for both of them, right? So in other words, it has to meet both conditions. So if it meets both conditions, it's greater than or equal to 70 and greater than or equal to 95, then it would meet both of those conditions. It would be shaded from 70 all the way on, wouldn't it, to the right. So what you want to keep in mind is that if it isn't contained just between two endpoints, as long as it meets both of the conditions set forth, then it is still an and one. Or means one or the other. And sometimes there's even overlap there. Okay? But typically there isn't. So I'm going to put this, I'm going to put X in the middle, I'm going to put 70 down here, I'm going to put 95 here. Yes. And what? Oh, no. Okay. I thought I heard somebody say question. Okay.
Bless you.
Oh, bless you. Is less than or equal to, is less than or equal to, because they're both included. So this says 70 is less than or equal to all the numbers that are shaded, and that's true. 70 is the smallest number up there. And the shaded region has to be less than or equal to 95, and that's true also. So here's our compound inequality, algebraically represented with a graph. We describe what that variable is representing and what that shaded region is actually showing us. All the possible temperatures the iguana's cage could be. By the way, would there be any restrictions on this temperature? Can you have parts of, does temperature have to be measured in whole degrees only? No. Are there any, even if there was negative in this graph, could we have negative temperatures?
Yeah.
Sure we could. So, remember, whenever we know what the variable is representing, we always think about, are there any of those, anything in that shaded region, anything in that inequality that I would have to say, you know what, here's a restriction, it can't be this, or it needs to be this. A temperature can be measured in parts of degrees, and this is all positive temperature, that's okay too. So I don't think we have any restrictions on this one. Okay, that's it for our notes for today. So you're in your homework that you're doing for tomorrow. I think what you're doing is just practicing what we did here. You should be probably practicing what we did in today's notes, and then we'll combine what we did in yesterday's notes with today's and do some more practice tomorrow on all of it. Okay? So any questions or concerns? Okay, I have to stop my recording and then I'll put it back so those of you who weren't keeping up can check yours over.
Just ran.
I gotta make sure your recording stops. Okay, I'll leave that up there for those of you who are up there. No, try to use this time for homework. You use passing time. Not last time.